to the lesson overview 1.06 Triangle Proportionality Theorem Part 1. In this video we're going to prove the angle bisector theorem and prove the Pythagorean theorem using triangle similarity. We're going to solve problems using both the angle bisector theorem and the Pythagorean theorem. The triangle proportionality theorem proves that if a line parallel to one side of a triangle intersects the other two sides, then it divides those sides proportionally. It is also sometimes referred to as the side splitting theorem, which you will see in a lot of your exit ticket problems. The theorem proves that A over B is equal to C over D, which shows the parallel line in the middle of the figure dividing the left hand and the right hand side of the triangle proportionally. Informally, we would say the upper left divided by the lower left and the upper right divided by the lower right. We would cross multiply to solve for missing links. So here we're going to substitute the information, setting up a proportion so that you can solve for missing links in a problem. Notice that we have A divided by J is equal to C divided by K. This is the whole left divided by the whole right, and they should equal each other. Notice that we can also divide B by J and D by K, meaning that we've added up B and A to get J, and we've added C and D to get K. The same would be true with AC and BD. It doesn't matter how you set up the proportion as long as you make sure that the corresponding sides go together with each other. So here we're using the corresponding sides of BD equal to the entire side of J over K. Let's see how this works. So here we're going to solve for X. Notice that the first thing that we do is identify the proportional sides. So CB is 5 and BA is 7. CD is 4 and DE is X. Substitute the known values and solve the proportion. Cross multiply. We get 5x is equal to 28. 28 because 7 times 4. Solve for x. We find that x is equal to 5.6. When we plug in 5.6 for x, we see that 5 divided by 7 is 28, and 4 divided by 5.6 is 28. Therefore, they are equal to each other. What is the length of AC? So here we're going to identify the proportional sides again. AB divided by all of AC. And then we're going to equal that to ED divided by EC, all of this line. So we would substitute the known value by saying divided by AC is equal to 16 divided by 24. Cross multiply. Notice that they've used AC as our x, because that's the length that we're looking for. AC is not separated because it's the entire line segment. So we get 16 AC is equal to 288. Therefore, AC is equal to 18 when we divide both sides by 16. Go ahead and check your work, and you see that both sides are equal to 288. Here we're going to go ahead and solve for x. Now they've given us an x, so we won't use line names. We're going to identify the proportional sides, the upper left divided by the entire left side, which is 15, and the upper right divided by the entire right side. This is going to look just a little bit different because we're going to add some sides together here. So we see 9 divided by 15 is equal to x divided by 20. We're going to cross multiply, and we get x is equal to 12. If you have any questions on this lesson, please reach out to me via email or text.